Hi, so we are the PC Chop Shop. Uh, our project is a web application that gathers data about used PC parts from Facebook, eBay, and Craigslist and keeps track of the prices of all the individual parts on there so that you know whether or not you're getting a good deal on a certain individual part. Our group members are Austin, Jordan, Jacob, and myself, Kevin. So I'm going to talk a little bit about the context or the idea behind our website. So the basic idea is that we want to make searching for used PC parts easy. There are a few problems with searching for used PC parts currently. The first one is that there's a lot of different websites. There's eBay, Facebook, Craigslist, Amazon, Mercari, Newegg, and that's just a few of them. The second problem is that a lot of sites only allow you to search one location. Um, or if you want to search in a different location, it requires a different site or search. A good example of this being Craigslist. The third problem is the price. The price can vary from website to website, of course, and of course it will vary over time. A good example of real world prices when cryptocurrency mining was at its peak, it actually made graphics cards artificially expensive, meaning you were paying over MSRP for a second-hand graphics card. The same thing also happened with RAM, and that was due to production shortages. Um, and so, really, our idea was that, hey, there's no website currently that we know of that tracks used PC parts. We knew that PC Part Picker does this for new parts, but we really wanted to focus on used parts. So, onto the design of the website. Uh, very early on, we decided that only having one website isn't good enough. We need at least two to be any sort of useful, and we really wanted more than two. We decided on three, and we decided on Facebook, Craigslist, and eBay. And we went with these because they're the three most popular uh, websites for selling anything, basically, not just PC parts. Um, Another early decision we had to make is what language we were going to use. A few of our group members were already familiar with Django and Python, so that was what we went with since it's familiar and they're both very easy to learn. Um, we went with Beautiful Soup for our web scraper uh, because Beautiful Soup is very widely used and it's easy to use and it has all of the features you could want. When it came to hosting our database, we went with Amazon Web Services simply because they provided enough storage and computing power in their free tier, so we didn't have to pay for anything. Um, for the database management service, we went with Postgres. It's not actually the easiest database management service to work with, but it's fully featured and it's supported and integrated well with Amazon Web Services. Um, Another design decision we had made was this must be a website. It must be accessible on the internet. And so for our website, we kind of defined two use cases. The first is that many people will be using the website from all over the world. The second use case is that just us, meaning the senior design project group, would be using the website. So there's a few issues with the first use case. We need to account for a lot of people searching at once, especially on the database side because that can cause data integrity issues. Um, we also need to grab the location and automatically determine which Facebook or Craigslist site to search. And doing this for Craigslist is actually quite a bit of work. It's not that easy. Another issue is that in our filtering, we would have to account for different languages and different kind of names for parts, which adds quite a bit of work to the filtering aspect of our program. Another issue is that you need to track every PC part for full functionality because we don't really know what people are going to search. And since there is no kind of master list of PC parts that have been made, this is actually a lot more difficult than we had anticipated in the beginning. Um, And so by focusing it on just us for the use case, we really toned down the scope of our project. We didn't need any advanced database features. We could have static locations. The filtering was much easier to implement, and we got to pick the parts we tracked, and we just went with the 10 or so most popular parts in each category. So the last major design decision we made was that just showing the parts and aggregating the data from these different websites wasn't good enough. We wanted to keep track of prices because this is what really allows you to determine if a deal is good or not. And we decided that we really only need to keep track of the daily average prices. And from there, we could do any other calculations that we might need. So that basically covers the idea behind our website and a lot of the major design decisions that we had to make.
So our first major milestone was actually implementing our eBay API to our website. At first, we were just started off with a plain search bar where you could enter stuff in, but nothing would populate. So when we implemented that eBay API, we could actually see tangible listings that were live from the eBay website. So this was kind of like our first proof of concept to show that we could actually do something like this. Our next major milestone was actually hosting our database on AWS using Postgres, because before we were all working on individual instances of our own databases on our local systems, and so that means we had very inconsistent data between each other. So when we had it all hosted on the internet through AWS, we were dealing with the exact same database, so that synchronized our information, so we knew we were working on the same stuff. Next was actually creating our Facebook API. Getting eBay and Craigslist, there's already existing APIs, so all we had to do is implement them. We weren't even sure if it was quite possible to create a Facebook API and actually hit theirs, because no one has done it before, as far as our research could tell. And there's a note of somebody doing it based on the mobile website, but we were actually able to do it hitting directly their front end desktop website, which was very nice, as well as grabbing the location data and those listings. And generally, that's where you find the cheapest prices on parts, or you can find the best deals, and that's where the best arbitrage opportunity exists. And then our final milestone that was really good, and we also didn't know if we were going to be able to do that, but was actually getting it hosted on the internet to where anyone could go see it. Before, we were all just running it locally on our machines, and it was working, but being able to host it and share it was really cool, doing that through Python Anywhere. As far as the tools we used, obviously our number one tool was using Python, and we used a number of different packages. But some of the main packages we used were Django for our front end framework, or for our back end framework, and dealing with the template language and all of that. We also used the eBay and Craigslist API, which was huge in getting our data. Beautiful Soup and Regex were both also huge in using that and scraping the Facebook data. There's a number of other smaller APIs that we used, but these were the main ones that really gave our site the full functionality. Another one I can think of was Chart.js to populate our graph data. Then our next tool was Amazon Web Servers with our relational database and Postgres. That's what we use to store all of our data, to hit the historical database, and also populate entries faster. We also used GitHub for source control, keeping everything sunk between all of our machines. And then Discord was really huge, especially during the whole COVID-19 crisis, because we were able to communicate very efficiently and effectively between each other. And then lastly was Python Anywhere, where we eventually hosted our website for, it was relatively easy being able to do it all through there because they had all their tools set up, which was a great learning experience too, just to understand how all that works, working with the Bash and Linux terminal, and getting that also connected to our Amazon Web Servers. So those were the tools we used.
Hey guys, I'm Jordan, and I'm going to be talking about our final product and some of the roadblocks that we hit along the way as we got to our final product. First things first, there's two parts to our final product as it stands right now. There's the search part of our program and the historical database. So as far as the search goes, our search queries across Facebook, Craigslist, and eBay. We're really happy that we got all three of those to work as well as they do. It takes in a location to narrow down the search for Facebook, and then it returns a list of all the results that can then further be sorted and searched to find different items. The historical database allows users to check if the price that they're seeing for a given part is high or low for the market average over the past several days or weeks. So let's jump right into some examples. The search bar is fairly similar to everything you've seen before, but if I move myself down a bit, you can see that now we've got a navigation bar across the top of our page. This allows users to jump between the home page, that search bar that we have here, and the historical database. The other thing that has changed is you'll notice under the search bar, there's now an enter Facebook location. That's what I was just talking about, that allows you to narrow down your search location to a given city or state. Once the user searches, it displays a much nicer now looking table like this. We've got the part listings website, the part title, the price, the URL, all sorts of different things. And as you can see from the example here, we can query things other than computer parts. So our program can be used for many other applications as well. Each of these columns can be clicked on to sort, with the important one probably being the part price, meaning you can sort by ascending and descending price, as well as you can see right below my face, you can search for different things such as face, as in Facebook. So this is only showing the results from Facebook right now. After clicking on the historical database tab on the navigation bar, you'll be taken to this page. This allows you to search for different computer parts, as we haven't expanded our database past computer parts. So you would select the part type, like a CPU, graphics card, hard drive, the manufacturer, Intel, AMD, NVIDIA, etc., and then the model. So that's that specific i5 processor, things like that. Once you hit submit, you'll be presented with a graph that's similar to this. We've got some random plot points in here for the purposes of demonstration, so we can see a pretty wide curve. And as you can see, you're able to pretty dynamically see the prices, both low and high, over the past week here, allowing the user to really gauge whether the deal is a good deal or a bad deal. Some of the roadblocks we hit along the way with this: Facebook was really difficult, as we had to build that all from the ground up, from scratch. eBay and Craigslist were much easier, as we were able to find other implementations to base our work off of, but Facebook didn't have anything like that. The data sets are also kind of an issue. There's a whole lot of different computer parts, as you might guess. And so building our database to work around all of those different parts was quite an undertaking. It wasn't that it was difficult work, it was very time consuming and tedious. We also ran into some issues with Google Chrome and Firefox. Firefox, their JavaScript is more up to date than Google Chrome. And we noticed that we were starting to run into issues with things not displaying and things breaking because Chrome was outdated. We managed to figure out how to work out some of those bugs, but that was a pretty big roadblock for a bit. And finally, the dependent dropdowns that you saw on the historical database that allow you to choose a CPU, and then the following dropdown changes its selection criteria to fit graphics cards or CPUs. That was pretty difficult to figure out, but we eventually got that to work. It just did take quite a bit more time than the other items. Now that we've talked about where we are, we're going to switch it over to Jacob. He's going to wrap up this presentation. Thank you.
I'm Jacob Silva, and I'm going to talk about our lessons learned. First, with our backend. We learned that APIs are not set in stone, and they may change mid-development. We had this issue with the eBay API, where it was updated mid-development, and we had to change some connection requests, update our packages to deal with this issue. And it taught us that the things that our program may be built using might change, and we need to be able to adjust for that. The next thing we learned was clear and organized database design. In the beginning, we laid out a preliminary plan for our databases, and we knew what we needed, but we didn't have a set design, and we just kind of rolled with that until the end, when we were building the front-end historical page and utilizing our historical database. We ran into some issues of finding the data we needed to find. So we learned to keep it clear and organized and set in stone. Furthermore, when tracking PC components, we learned that you can't track everything, and it's unreasonable to track everything. Some little part from 10 years ago is not important. Nobody cares how much that costs. So we decided to pick the top selling. This kept our data size small but relevant. In conclusion, we learned that scheduling a task, such as a cron job, which just runs based on system time, it allows you to run a script every 5 minutes or every hour, every 24 hours, whatever you'd like, is different on different hosting services. On Amazon services, you use it on a Unix terminal, and it's all coded in, and it's super easy. We used Python Anywhere, and it was different here. So our cron job was not running like it was supposed to, and we had to adjust accordingly. Next, the front end. We learned that just because something works on one browser doesn't mean it works on another. This came in the form of the Firefox Chrome issue, where one page would work on Firefox, but it would not work on Chrome. So we learned we need to test multiple browsers to make sure everything works across the board. Another thing we learned is that good front-end design comes from a solid back-end. Without the back-end, you can't design the front-end. You can design a rough idea, but without knowing what you're working with on the back-end, there's no way to make a nice and complete front-end. Furthermore, we learned that a nice, pretty, intuitive user interface makes all the difference. We had back-end working, and our front-end we hadn't started working on yet, and it just seemed like a list of information. And once we got that sorted, we added some images and some usability features. It really made it into a product more than just a, just a school project. We also learned a few things about project management. First, setting achievable goals and meeting these goal deadlines is important. We were super good about this on the first half of the project, lacked a little bit around spring break and the COVID-19 fiasco, but we picked it back up on the final push, and it really helped us complete our project. We also learned that issues will come up, and it's best to deal with them then as opposed to later, because when you do fix them, other things might change, and you don't want to be dealing with that when you're trying to deploy the app versus when you can just deal with it right away. We also learned to plan deployment. So with Amazon Web Services, they plan to have you, build the basically a repository for their hosting service before you build a project. That's another reason we didn't go with them and we went with Python Anywhere. It's because Python Anywhere allows you to easily upload a Django project without having to plan that beforehand. So we learned plan the deployment before you start so you can use what you plan on using. We also learned good team communication makes the whole process smoother. Towards the end, we were all in the Discord quite a bit, talking, working through things, and it really helped move progress along as opposed to just sending a message here or there. Next, I'm going to talk about project feature. Currently, we plan to keep our project hosted for anybody you use who has the URL. On top of this, we plan to use it for personal use, for things such as buying parts, finding cheap prices, and we could even use it for the foundations of a business of pricing out or building used PCs and giving consumers good deals. On top of this, there's currently no more plans to add extra features, but we haven't ruled the idea out. If something comes up and we think it needs to be added, we could definitely add it. The project will also be used by everyone in the group as a resume builder, something to show employers that, hey, we know how to do something. In conclusion, I'm going to talk about team member roles. So first up, we have Austin. Austin worked really hard on the Facebook API in the back end, on top of the front end with our historical lookup page and the HTTP requests that go along with that. It was a real pain. He put in a lot of time on that. We also have Jordan, who worked heavily on the front end. He designed the home page, he designed the historical page, and the search results page. A lot of the things the user will see, Jordan put some time into. He also helped with the back end with the scrapers. Then we have Kevin, who was a back-end programmer, worked a lot with the eBay API, the Craigslist API, and the overall back end of the program. He also set up the Amazon database and did a lot of work with the database design. Finally, me. I was a back-end programmer. I worked a lot with Kevin on scrapers and APIs, and on top of that, I helped quite a bit with the database design itself. Thank you.